last product or last part. So instantaneously the stock will get, and the stock quantity will go up. Okay, this one. So as soon as again it consume that material from maximum level to the minimum level, so again the new stock will come in, join the inventory, and suddenly the material level stock inventory level goes to maximum level. Here you need to understand that here for bringing the material or purchasing and transportation, everything negligible time. Okay, as soon as it's goes down to minimum stock, immediately within short span of hours the material will come and into the inventory. So here the lead time is almost at zero. Okay, so because we know that what is the demand and how much almost consumption will be. So based on that, we will inform to that vendor or supplier. So because it's fixed quantity, he will keep that amount like every 1 month. Okay, so every month 31st I have to deliver. So it means by end of this 31st in our factory, material will consume by 6 o'clock. Factory will get closed for production up to 6. So warehouse people will stay 2-3 hours. By that time 31st 6 to 8 or 6 to 9 supplier will come and deliver the material. So there is a no production delay.
Sir,
Okay,
will that consumption rate will be constant or it will be raising or decreasing, sir?
here the fixed. Okay, so even see, in 30 days, I assume that this consumption days is 30 days. Sometimes they will plan 1 week. So in that 1 week, 1 day will be around 100. Assume that this consume rate is days is 1 week. Okay, and parts okay around uh, 100 or 70. Okay, first day will be 10, or some second day will be maybe there is no consumption, and third day again it will take 20. So on an average the weekly the consumption will be 70, like that they will calculate. Yes, around 1 or 2 or 5 to 6 will be in stock, but that is a very negligible amount compared to that maximum value. Okay, your doubt is clear?
Okay, sir. Sir,
Okay.
then in such cases like now it is at present Corona is going now, sir.
Yes.
Then the consumption will be completely stopped. Then it will be somewhat different now, sir, for this one.
Okay. Yeah, in that time what will happen? So immediately they will inform to see if something goes like that, even your production also will get stopped, right? So in that production time, when it stopped, we'll inform to all suppliers. So next week onwards, our all purchase order will be going to stop. So don't send any materials to the factory. So what will happen around February month, due to Corona or COVID-19, our production is stopped. Okay, February, and assume that this consumption period is annual. Okay, every December they have to deliver the material. So what will happen every month? So after February, the March, whatever the material they are going to send, will based upon our mail communication or through phone conversation, generally they will stop for delivering the material in warehouse. So in that case, you will be having only one month. If you respond very quickly, there will be no inventory. If they conveyed very lately, so already transportation is started, invoice, everything prepared. So in that case, once state is changed, they can't do anything. Again, they have to bring to our factory and keep it that 1 month inventory. So that is again negotiation. Either both have to bear 50-50 charges. So these things are happened. Okay. See, there is a one case happened in insulation material. So what happened, based upon order we procured. So PPC people, production planning department people, they forget to inform that particular order is stopped or changed. So what what in the meeting they raised that the material is already inside the factory. Okay, then obviously they will catch hold the purchase people. So in that case, we'll again go to MRP controller. MRP controller is something like everything is scheduled stock you can see in SAP or Oracle. Okay, so based on that, okay, this order is closed on February because of customer changes, but they already in February, they have to, example 30 February they have informed to PPC. Immediately they have to inform to purchaser, because March they have to release purchase order to call that material, but they forget we already released 1st March. So April 1st they PPC, we received the material. PPC people they come and shouting on purchasers, okay, why the material come into the factory. So simply we can go back and see the MRP. Okay, you receive the information from contract management that stating that the project got cancelled, but March we release the purchase order. If you might have informed to us at least 1 month in these 30 days, we might have stopped to release purchase order. Okay, so now whatever the material we received, we can't send it back, because including transportation, the transportation charge is very huge because it is imported. So this is the problem generally. Yes, some cases occur. So yeah, you will face this kind of situation in factory, but there you have to be very careful. With the proofs only you have to tell. Okay, so you understood, right?
Yes, sir.
Okay. Next, we discussed about the problems. Okay, we'll go quickly the model 2. Now the model 2 is the production model. Most of the companies, see, this previous model is most of the time, see, it's very basic components like already made products. So those products only for bring the material and assemble. So those, for that you no need to bother much. Yes, you have to careful, but mainly the problem we have to we will face in production model. I am telling this production model means here you need to have from starting to ending, until receive the material you have to be follow material. Example, I am uh, I'm a manufacturer, MRF manufacturer. Okay, so generally for MRF, the car body or like MS or whatever the SS grade or whatever the body, so it will come from Jindal Steel or Tata from their manufacturer. Okay, sometimes they will import from China because its cost is very less compared to Indian price. So in that case, what you have to do? So if you are saving some product, means you have to be very careful until it's reached your factory with good quality. Because example, the same body MS material you are procuring from Jindal Steel. There you have to have a follow up, like you can go to maybe Jindal in Rajasthan. So you can go there at least, because transportation charge is very less. You can go there, inspect after releasing purchase order. Okay, so even if you have found okay, this material grade is whatever I am asking, that is not fulfilling my requirement, so you can stop immediately and you can give that order to another supplier. But yes, if the Jindal is giving correct grade, so what you have to do? Okay, give okay to them, and you can supply within as per my uh, purchase order, as per the lead time. Okay, so in that case, you have end to end physically you can interact this kind of follow-up will be very clear. But if you are think that, see, this month I have to, my appraisal is coming, so I have to say more to the company. In that case, I will see where this same material is available in outside country or inside India, okay, inside our country. So sometimes we'll find that we'll go to China, okay, their material cost is less, okay. So what, in that case, you don't access much to see the material, okay. So in that time, sometimes you might have face some surprises, or sometimes some good suppliers, they will send the material as per our requirement. So complete this process will take production order, quality check from their end after receiving like transportation, and quality check in our end. So this entire process, okay, it's called lead time. Already we discussed. Okay, so you can see this triangle as we discussed. This is stock level. Okay, this maximum inventory level we already discussed, and this below production time. Okay, so this inclined line, you can see this is stock buildup. Okay, so this is the time where TP is production time, okay, and this is consumption time, okay. This from here to here, again this cycle will repeat. Here you have to be make sure that order cost is not changing, okay, with the lot size. So this is demand rate is almost fixed. Every month I am going to make around 10 cars, okay. So for that, demand is fixed. So, and the D is the demand rate or consumption rate, and the P is the production rate, and the T is for replacing the consumption and placing during takes place during the entire cycle. This complete time we called as T, starting from stock buildup to consumption rate. Okay, so here the inventory under the situation is buildups at the rate of P minus D. So the units and inventory is maximum at the end of the production rate. That is this here, this point. Okay, so maximum inventory at the top end of the production, P minus D into TP. Okay, the average inventory is already we discussed. So P minus D into TP by 2. The quantity produced during the production period. Okay, that is how much quantity we have to produce in particular time. So that is this is TP from here to here. Okay, and the production rate. Okay, so when you substitute the TP here, what will happen? So we know that average inventory is Q by P. So P minus T into Q by 2P. So Q by 2 into 1 minus dP. See, almost this complete derivation is similar to the previous model. Only you can have it more on here, this part 1 minus d by P. Apart from this, we can see the final equation also. There you will have under root 2D C naught by CH. Okay, to demand and ordering cost and holding cost. Here extra you will have this 1 minus dP. Okay, and so the annual setup cost is number of setup cost into setup cost per setup. Okay, so that is this Q by 2 into 1 minus dP into holding cost. Here normally we discussed more on economic order quantity. Here we'll discuss also economic batch quantity. Okay, so most of the time there we here we'll discuss batches wise. Okay, this because why we are discussing batches means here production is we are doing some materials, we are producing some material. Okay, so how much rate this we have to produce. Okay, so what will be the economic order economic batch quantity? See, if I produce instead of 100, I produce 250, so obviously there will be loss. So there previously by ordering the material, we concentrated more and how much we have to order so that our company will save side. That part we discussed EOQ. Here this is production model. So in production model, how much material I have to produce or how many material I have to manufacture so that my company will get better economically production rate will go through. So those we'll discuss here because this production uh, rate will discuss more. So if the inventory carrying cost is expressed as a percentage of annual inventory, so this already we know the formula. Extra we'll have this 1 minus dp into I. Okay, this is annually. Okay, so optimal cost is given by same as it is, so extra this one, and optimal number of production is annual demand by economic batch quantity. As you can see here, there you will have economic order quantity, but here you will have economic batch quantity, that is Q star. Okay, as it is, I will at the end of the slides, in middle I will show to you how to simply changing these formulas. You no need to derive all those things in exam, but you need to understand the remember the formulas, especially if you remember first model only 3 formulas, remaining the 2 methods you will remember easily. So that slide also I will show, no need to worry. So simply we'll go to one problem. So there we discussed orders. So here we discuss production. So example, a company produce a cable at the rate of 5,000 meter per hour. So there is a company, okay, so that company is producing 5,000 meter per hour a cable. Okay, the cable is used the rate of 2,500 meters per hour. So the cable, okay, whatever the cable the company is producing, so that it is going for the usage that is 2,500 meters per hour. Okay, the cost of the cable is 5 per meter. Okay, the inventory carrying cost 25% and setup cost is 4,050 per setup. So determine the optimal number of cycle required in a year for the manufacturer of this cable. Okay, so uh, you can read the question once again. So I'll start to explain this. Okay, so we'll go as it is as per the formula and the question. So there is a company. Okay, their demand is 2,500 meters per hour. We know that demand notation we use sometimes this T. Okay, the production rate P is 5,000 meter per hour. Okay, that is capital P. The price per unit means per meter they will charge around 5 rupees. Okay, inventory carrying cost is 25 percentage. Okay, setup cost is for one setup or ordering this around 4,050 per order. And demand, see, this is the demand you have to be calculate annually. Okay, so per demand per hour is 2,500 meter. So assume that so per day the company will run around average 8 hours, most of the companies. Okay, so 2,500 per hour into 8 hours per day and 365 days. Okay, So this is the demand, and economic batch quantity we have to calculate. That is under root 2d C naught by 1 minus d by p into ch. So demand we know this value 2500 into 8 into 365. So you can substitute here. Here this value I put around 2500 into 8. You'll get 20,000 into 365 this per year. Okay, so sometimes they will give instead of 365, the company will run only 360 or 250 days. In that case, you have to make sure that this value should be something around 250 or 300 according to the working days annually they will mention. Here I am taking the 365 days the company will run. Okay, so the unit like 1 minus d by p into ch. So this ordering cost, actually this will go to here. So you will get this value. So after that, they are asking that the number of cycles required in a year for the manufacturer for this cable. But how many number of cycles, like as I said previously, the triangle. Okay, so those how many triangles will come? The triangle means production time and the consumption time, around 24 times how it will calculate. So that is annual demand by economic batch quantity. The D we know, the 2500 meter per hour and 8 hours and 365 days by economic batch quantity around this one. So it means 24 cycles will come. So per annum, it means 24 times we have to release that order. Okay.
Sir, why we are taking 8 hours per day, sir?
Yeah, it is. I'm assuming. So you see, sometimes they will give in question 10 hours, sometimes they will give 24 hours, run 3 shifts, the companies are running. See, in this problem, I assumed based on my previous company hours, working hours, I assumed that and I put it here. Okay, but sometimes they will give maximum, they will give working hours and how many days they will work in annually.
Sir,
Okay.
if they don't give, we have to assume any time,
You
sir.
see, in that case, you have to mention very clearly. Assume that you mention hours. See, when we go for corrections, if some questions will come like this, what we'll do? Sometimes the faculty, when they go for moderation, based upon the question, they will give the data. Okay, sometimes if they forget, they already proceeded the exam for the students and they assumed some students 8 days, some student 10 days. In that case, the faculty has to do the calculation according to whatever the students assumed. You understood, right?
Yes, sir.
Okay, so that party will generally faculty will take care when they go for before starting the exam. There is a process called moderation. So in moderation, the process like is there any units they put wrongly or any typing mistakes happen or these kind of assumption data anything missing. So these kind of things they will generally observe. If they forgot, the process is like this. Okay. Next thing is one more problem we'll discuss. A contractor undertakes to supply diesel engines to a truck manufacturer at the rate of 25 per day. Okay. He finds that the cost of holding a completed engine in stock 16 per month, the production of engines in the batches, and each time a new batch is started, there are setup costs 10,000 rupees. How frequently should the batch be started, and what will be the minimum average inventory cost and production time if production rate is 40 engines per day? Okay, just read the question once again, all of you.
Sir, in inventory carrying cost it is 16, no sir, 1.6 you have given.
Hello. Hello. I'm audible. Some signal drop.
Yes sir.
Hello. Okay.
Yes,
Have you read the question?
yes sir. Sir, here inventory carrying cost it is 16, no sir.
Yeah, this is 1616.
Here it took 1.6, no sir.
Yes, yes. Okay. So in this question also, I assume that 300 working days. Okay. So in this question also, the assumption data is required. Okay. So here the 25 days demand rate 25 per day. The production rate is 40 per day, and annual demand is 25 into, so demand per day into 300 working hours, I assume. So that is 7,500 per annum. So inventory carrying cost, this is per annually. Okay. So setup cost is around 10,000. So obviously, whenever you doing this production problem, you have to find the economic batch quantity. So this value, you know that demand and ordering cost. So simply you just substitute, you will get this. So number of production runs per annum. See how many production runs it has to do. Like this is annual demand by EBQ. So 2 orders. Okay, and the frequency of production run is off. Okay, it means around off, like 6 months once it has to run, and the total annually inventory carrying cost is equal to 32,860. This is simple calculation everyone can do. Only I want to show that the slide where you will understand that the formulas. See, once you go to exam, so there is a three kinds of formulas you need to remember. There, so most of the times I will take you to the first this. Okay, so all are you can have see this model. This three models. One, this is two, this is three. So first model, the instantaneous replacement. As soon as the material consumed, the immediately it will get rise. Okay. Second one is as similarly in first model, as soon as the consumption is done, so immediately we rise the order. In production model, what we discussed, as soon as the material get consumed, so what will happen, we'll production this inventory will goes, the production rate will go increase. Okay, and it will reach to the top maximum level. Again it goes to down. Okay, parallelly it will increase. So you can see these formulas, there is almost three in this. So economic order quantity, EOQ, So this is we already know. So here most of the times in holding cost means for, see, I have 10 mobiles. Okay, 10 mobiles. If I keeping in my shop, okay, what will happen in 1 year? So that 100 mobiles into the interest of each mobile, it's around the total annual inventory holding cost. So that is EOQ. So 1 second. Okay. So here, most of the times they will give holding cost. If they are not giving holding cost, they will give cost per piece and the interest on per piece. So in that time, you have to apply first this CP into I, then put that into inventory holding cost. Then you can find this EOQ. Another thing is, see, I'm going in the horizontal way. Here, economic batch quantity, this is, okay. So here, as I said, extra in holding, you will have this production changes. So that is 1 minus dp. So you can see here in next method, what we are going to discuss, there you can have this extra. Okay, so again I'm going here minimum inventory cost. So that is under root 2d c naught ch. The same formula we use for second method and third method. Extra we are getting this. Okay, and this one. Similarly, total annual cost. How much total we spend annually. So for that you need to have this same formula. Extra for holding cost, you will have this. So this anyway, when I give this, you just note it down. Okay, we'll see third one. So here the shortages are permitted. So example, there is a one, I'm running the company. So in that case, what happened? So I don't want to release purchase order. See, uh, we'll discuss like this. Okay, my uh, requirement is every month around 100. Okay, and every month I have to release one purchase order. Okay, so uh, they will deliver with the minimum quantity of 20. Okay, it means if our requirement minimum, if we have, if we ask, see, I need two materials, two parts, they won't deliver. They will deliver only based upon the minimum order quantity. Okay, the minimum order quantity is something like, so they will see their uh, uh, the profit and the transportation, everything they will see, and they will send the material according to the minimum order quantity. If the see, now my material is over, so in that case, so we required now 5 6 materials. No, we are not receiving the material because they are not supplying. Because why? So that extra, whenever it reaches to, when we release the purchase order for 20 only, they will bring the material. Until that, what is happening? My customers are waiting to get the material. So in that process, we generally we call it a shortage. Okay, so here the method is shortages are permitted. So why? Because the to avoid extra transportation charges from the company or supplier or vendor, for that we are allowing that shortages in the uh, uh, production, so that whenever it is reaches to the minimum order quantity, will immediately will inform to the supplier, so they will bring the material. Until that, so we can't give the material because that shortage is happening. So that's why you can see this, the consumption is some maximum stage to assume that O, it reaches to O. So in first method, instantaneous replacement, once the material is over, the same day or within 1 day without shortage, material will come and join the inventory warehouse. Okay, so there will be no shortages. But here, even though it is getting shortages, they will wait for some time until it reaches to minimum order quantity. So then only it they will send the materials to the company. So that is this, the time, generally the number of shortages called order, this one, few minutes. Now we'll see some notations here. CS is the shortages cost. Okay, this one per unit per period. S is the balance units after back orders are satisfied. Okay, so this one is back order means whatever the we need to get the from suppliers. Okay, so that is back orders. Okay, so q minus is number of shortages per order, this one. T1 is the time period during which inventory is positive up to here, T1. So how much time without getting any negative any shortages. Okay, so that is T1, and the T2 is the time during the shortage exists. This is this period. Okay, and capital T is the time between receipt of orders. So starting from my material ordering, after receiving the material quality, everything over, from that time to until it goes to again next to release the purchasing order. So this complete the time is around, we called as capital T. So same formulas, the no loss of sales due to stock out of charge shortages. Here one assumption is due to that, so we have to request our inside the factory people. So supplier or vendor is not supplying the material because of uh, minimum order quantity we are not meeting. So in that case, what they will do? So they will do another works, whatever the pending orders or whatever the productions work they have. So they will keep idle this work until the material reach to our factory. As soon as they receive this material, so they will take up this material and they will go ahead. So that is one assumption here we'll have. So apart from this, economic order quantity, so same, and optimum remaining units after back order. Okay, so optimal amount back order, total amount of inventory cost. So this already we have. So this already we discussed. It's very simple formulas. So here, but most of the time this they will give 10 marks question. But you can see if you try to understand the question and you try to identify the which model, production model or back order models or shortages model or stock replenishment method, you easily you can put the formulas. And but in that you have to check annually they are asking, or they're asking cost per piece or interest. So these things you have to be read very carefully. So the demand for an item is a uniform at the rate of 25 units per month. Ordering cost is 30 and cost per unit is 2 per unit. Inventory carrying cost is 0.5 per unit per month, and shortage cost is 0.3 unit per month. Determine the order quantity, okay, and how often to make production run. Just read once again this question. Okay, so this problem, everything you can see everything they have given in terms of month. Okay, so you have to consider the entire, if they are giving any in annually, you have to convert into months and you have to do. So here what extra words will come, that is shortage cost. Okay, apart from this, compared to first model, there is nothing. Okay, only shortage cost will come. That shortage cost, why? Because we wait the some time. Okay, so for that we have to get penalized from the customer. Okay, so that is shortage cost here. So here in this question, the unit, they have given this uniform the rate, so the demand, so that is 25 units per month. Okay, that is D. And ordering cost they have given, that is directly in the question itself, 30. And holding cost they have given, inventory carrying cost or holding cost, 0.5 per unit per month. Okay, and the shortage cost they have given here, 0.3. This is inventory, actually inventory shortage cost 0.3 per month. Yeah, everything we have. Just make this formula, because whenever you see shortage cost, there is a hint. Okay, that is a third model. So directly you can apply this, the root 2D C naught by CH. So CS plus CH by CS. So demand we know, that is 25 from this question. So 30 ordering cost from the question per you have, and holding cost per unit per month. Okay, yes, we have. And sometimes if they give per unit and per month, and if they give sometimes like interest, is that you have to multiply per product, and per product and interest if they give, you have to do CP into I here. Okay, instead of CH, they, if they give product cost and interest, there if the hint is, you have to apply here. Okay, and CS plus CH by CS. Okay, you will get 90 units. And optimal scheduling between two consecutive orders. Okay, so that is around 3 months. So you have to, that cycle, that this time consecutive order, that is every T will come around 3 months. Okay, so we'll go to next problem. The following information on production inventory system of manufacturing the company is given below. Okay, determine optimum lot size, manufacturing time and time between setups, demand per annum. They have given the unit cost 40 rupees, the setup cost 500, production rate is 3600 units, holding cost 8 per unit per annum, shortages cost unit per unit 20 unit 20 per unit per annum. So here everything they have given annum. Okay, annually. So in that case, just economic lot size, you can have this formula and just substitute here the manufacturing time, how much time it will take. Okay, so this is you will get 0.031. It means into, you make it into if you need to convert in a month, you can convert by 12, or if you want to take into convert into hours, you can convert. Okay. Next, time between setups. Okay, so that is Q star by D, that is 0.187. So this is each production setup that with including shortages, it will comes around how many setups? 0.187 years into, if you want to convert into, make into 12, you will get those many triangles with the including shortages. So anyway, these slides I will give just see and practice once again. This is just, so this kind of questions is very important. So most of the times in companies you will face these kind of situations. Okay, now we'll see. So monthly consumption of an items is 300 units. Okay, the price per unit is 10. Inventory carrying cost is 18%, and ordering cost is 36 per order. Lead time of 1 month stock, assuming ROL system. Okay, and they are asking pre-order quantity, pre-order level, minimum level, maximum level, average inventory. Okay, so here ROL system, pre-order level system, so usually under the quantity of economic quantity. Okay, it means in first method, what we will discuss, so as we have to find out the curve, like where our ordering quantity and demand and inventory carrying cost should be optimum. We discussed this line also. So there you will have the EOQ, economic order quantity. So here we also called as this ROL system. Okay, so for that, whatever the formula we use for the, we have to use here also. So for that, you will have 120 units of economic order quantity. Okay, so reorder level point, if you want to calculate, that is lead time consumption and safety stock. Okay, this is the safety stock and this is lead time consumption. Okay, you will have 600 units. So minimum level is this one. Okay, so that in that case, safety stock plus ordering quantity. So this safety stock and how much amount we can survive. So that is minimum level. So this one, if whatever the line, this red line we comes to below, that called as safety stock we are using. This nobody will allow to use. Okay, and this maximum level is, we know that safety stock we have to consider, and ordering quantity also we have to consider. Ordering quantity means, so whatever the we need to reach to maximum level. So here generally we release purchase order. Okay, so this is the safety stock, and order level is when you order you will reach to maximum level, this line. Okay, so that is 420 units. So average inventory is, this 420 plus 300, where there is Q, this one and this one, yeah, minimum and maximum level. So this average, to make the average you have to do maximum and minimum. You can add it, sum of, and by 2 you will get the average inventory. That around it will goes to somewhere around near to EOQ, but it will not EOQ quantity, but somewhere in between. this and this somewhere here it will go. That is half, okay, half of this maximum and inventory quantity. So as we finish the EOQ models, so you remember, right? Those three are very important. So you just practice. I will share that. So quickly we'll move to the some analysis. Okay. So in that ABC analysis, as I discussed in the previous classes, ABC analysis very important. How much quantity? See, if you see in the car manufacturing company MRF, okay, there are around 10 to 15,000 of different parts, starting from tire to including sensor, bolts, engine, uh, whatever the steering, around 10 to 15,000 materials, items you can see when you do the exploding view or disassemble model. Okay, disassemble parts when you do that. So, but how to, as I am an inventory manager, how do I categorize my material and how to give a preference to those materials? See, I can't follow 15,000 material each and every day. Okay, this material whether is going to below safety stock or bolts are going to maximum level or steering are going to below safety stock. I can't see that those 15,000 material follow. So to avoid those kind of situations, there is a few models. Okay, ABC, EVD, VED, PQ, some analysis will be there. So most of these companies they come follow 60 to 70% company this ABC analysis. After making this ABC analysis only, they will do this previously whatever we made this calculation like EOQ, all the models, categorization, second production model. So they those formulas will try to apply for those materials. Okay, to make whether the example some material when it's reached to up to reorder point, automatically it will get release one purchase order, it will go to mm, customer, supplier. Some materials they won't define like that. For that we have to see physically whether that bearing or steering or engine. Okay, so those kind of things we'll discuss now. First of all, ABC inventory analysis is not mandatory for business to apply in their supply chain management, but is highly recommended to avoid future unwanted errors and losses. As I said, uh, if they want to properly judge the material, if they want to spend more time instead of all those things, if once they do this ABC analysis, then they can go ahead to avoid delays or all those things, material delays. Okay, so you can see this graph. So x-axis is the percentage of total items, and y-axis is the cost, percentage of cost or revenue or profit other. Okay, it means I have around 100 parts. Okay, these 100 parts, and I have here percentages. I will do the percentages here. Okay, so now which one I have to categorize more? First one I have to categorize based upon the quantity and based upon the cost or revenue or profit. Now the ABC, the A category will tells about when you do the A category material, you have to do like this. The quantity of the material is types are less, okay, but the cost or the cost of the products or items the more. Okay, I'll, can you in the car, okay, what is the maximum cost in that parts in that part in the car? what is the maximum cost in entire car? There are 15,000, around 10 to 15,000 parts you can find in a car. What is the maximum cost in entire car you will have? Hello?
Sir, engine.
Yes, good. Next. After that,
Chassis.
uh, what would be the, like, chassis is okay, but chassis is just iron material, right?
Sir, internal luxury, sir.
Sorry?
Electronics.
Internal luxuries will be there.
Yeah, transmission system.
Electronics.
Yes, electronics, transmission. Yeah, these are the very high cost parts in entire the car. Okay, if you see that around 7 lakhs, one Ford car will be there. Around 2.5 lakhs cost will go to the engine only. Okay, and the transmission system. So this will take around 1.5 lakh. Okay, and we'll go to sensors. It's around
Yes, sir.
take one.
Braking system and airbag system.
Yes, that's why I'm telling transmission system. The around gears, brakes, everything goes there, right? Okay, so the more cost of the parts, okay, but the quantity is very, we can count. Okay, there is a one engine, one transmission system, one airbag. Okay, here you can see the total item, percentage of item, you can see here very less, orange one, but the cost of percentage cost is up to 80%. It's occupying the total cost of the product. That is A category. The B category goes like, as you said, like chassis. Chassis is okay, we can get it by immediately from our vendors. Okay, chassis. Something goes wrong also, we can request some people in that area. They can do some chassis. Okay, it's not good quality, but they can. This is second level cost. Okay, it's around 20 to 40 percentage quantity, not only changes another. This is a second level cost, but the quantity also compared to A category little bit more. Okay, the third category around 40 to 80, around 60 percentage of parts will lie on this C category. Includes bolts, nuts, your seat covers and wiper and lights, these kind of parts. Not only so many. Okay, the cost, but you can see the cost very narrow, very less. Okay, but the quantity of items from that product, it's occupying more. So for these, if you go to any company, any service, car service shop, if some accident happen, okay, is the Ford engine whatever they got damaged, if you ask that guy, okay, I have money, I will replace that engine, can you bring and assemble? They'll say, no sir, it is I have to order, I have to release purchase order, all those things they will tell, because there is huge amount involved and they won't, nobody will keep inside the service center. But if you ask, go there and sir, I some guy and them and hit my car and the lights are broken, they will say, okay, just sit in service center, I will replace within 2 hours, or you come back by evening, I will replace it. Because the inventory they keep inside the factory for this C category is more compared to A. Okay, that's what I want to tell from this. So once this categorize happened, they will fix this. See, every material having the unique code. Now I will tell how this will work in company. So every material, see, as I said, I'm taking the same example, the company of Ford or MRF. So that cars having 15,000 materials in that parts in that car. Each product, each part having some unique code. Okay, even even Bolt also they have a unique code. In that, once the categories happened A, B, C category, they will make the one Excel. They will put it in those A, B, C category and they will categorize. After this, they will take simply to SAP, SAP. So after taking that SAP, they will assign each material. Example, A category material. So I have my engine. The engine they will keep in some MRP controller. See, MRP controller is like your what I can say. Every day it will run. Okay, like I can say booting. Okay, so once your system start, what will happen? The complete system will get properly opened. Okay, and if any errors will get in that, what we'll do, we'll simply shut down. Okay, in company also, what they will do, every 24 hours there is a shutdown in MRP. So in that case, whatever the problems in previous day, it will get resolved and it will take new actions. So now the case is like, now there will be MRP controller A, MRP controller B, MRP controller C. A for C category material, okay, they will assign to MRP. Once for this, you no need to release daily purchase orders or monthly purchase order annually, because there are around uh, 10,000 materials. For all 10,000 materials, there is single formula. Okay, so once the material reach to reorder point, there is an alarm, immediately release purchase order. Okay, once it's reached to reorder point, immediately purchase order will rise and it will come to purchaser, or it will directly goes to the supplier. Sometimes it will, they will put in one setting, directly it will come to purchaser. So you will see the whether purchase in that cost is correct or not. Delivery dates, if they want to change anything, they will change and they will simply send to the supplier. For these 20,000 material, formula is almost same. Once it reaches to reorder point, immediately it will go. Sometimes they want to keep the back order quantity. It means in that case, our requirement is 10 until it goes to a minimum quantity. When it reaches to minimum quantity only, the purchase order will release and it will go. So this kind of EOQ system will run. Based upon that, it will go to purchase order. But for that, what is the main motto? Initially, categorization of material is very important. So that one will happen in ABC analysis. Sometimes the company will follow this ABC. Sometimes company will follow another method, that is VED analysis. That we'll discuss in the next slide. You understood, right? This slide. Hello. Hello.
Yes, sir.
Okay, because most of the times I saw this question in the exams, ABC analysis, discuss about ABC analysis with the graphs. Take some example, like that they've given 2-3 times. JNTU in question papers. Okay, you can see here A items which are very tight control and accurate records. Okay, why? Because the quantity, the price involving more in this. See, now I'm asking, if I keep that settings to this A category, what will happen if you don't come to see? You fix everything in SAP. Suddenly you fired from the company. The next person who is coming to your place, what will happen? He won't see what already assigned to A category, C category, because already that guy already made programming and as per the EOQ formulas, So it is running. So similarly, A category also, if it will goes to the purchaser, what will happen? If you don't see the bearing, minimum order quantity will reach. Even if you don't require also, it will goes to the customer supplier. He will deliver the material. After saying that, you will get surprised. So you will say, I didn't release purchase order. Okay. But management will come and ask you, just open your SAP. Why you have not changed? Why you didn't see this? A category materials are very, very high costly material. Okay, without knowing that how the purchase order will goes to the supplier. That is why most of the times only C category materials they will give to the direct purchase order release option to the C category, but A and B simply they will sit and do the calculation. See, assume, see, I used to do the calculation for placing the purchase order for bearings. Okay, so this is which bearing? So this is pedestal bearing or ball bearing. So ball bearing. So what kind of grease they will, what kind of balls? Okay, what kind of grade and from where it is coming? Okay, if it is a pedestal bearing, okay, whether it is having a thrust pad, what kind of thrust pad? So if it is a thrust pad is having, so what is the clearance? What is the tolerance? So all those things, even though people will say you are purchaser, but you should have knowledge of the technical. Then only most of the companies purchasers are technical background, either mechanical or if it is related to ECE, they will basically background from ECE background, electrical engineers or electronics engineers, and they will order generally if any panels are required. So those kind of times, the purchaser should be an engineer. Okay, it's not like purchaser is just a financial guy. No, they won't allow any financial guy to sit in that purchase. Okay, I hope everyone clear in this ABC analysis. So next is VED analysis. So VED analysis is almost similar. Okay. The V stands for the VED analysis is an inventory management technique that classifies inventory based on its functional importance. Means first we'll go for classification. Vital, V for vital, E stands for essential, D stands for desirable. So vital means the vital category includes inventory which is necessary for production or any other process in an organization. In any such inventory is unavailable, entire production may stop. See, if therefore the order such inventory should be beforehand. See, you are for this example, if any college, okay, the primary motto is the infrastructure is vital. Okay, without infrastructure, how they will run? Example, a lab. If they don't have the infrastructure or equipment, how they will conduct the laboratory? Okay, so that is vital. Here the vital part or vital material is the missions. Okay, so yes, if you have a machine, you don't have infrastructure means buildings. Even though if you keep somewhere outside also, if you have a power connection, you can run. But even if you don't have the machine, you have all the buildings, there is no use to here. So that vital part is, if that part in that function, without that part the function will not happen. So that kind of product will comes under vital. The essential is, the essential category includes inventory which is next to being vital. So loss due to their unavailability may be temporary or might be loss possible to repair in stock item or part. Ensure optimum availability and maintenance. Here the same example I'm taking, but I'm changing another way. So same, you have equipment, okay, you have infrastructure, everything. Suddenly when it is running that machine, the power somewhere transformer got burned. Okay, due to that reason the machine will get stopped? No. we'll try to go to another source, maybe the battery or transformer, generators, okay, to run that machinery. Okay, so until it get stopped, that generator, we have to be careful that availability of that transformer or power supply should be preponed or properly maintained. Okay, so next thing is desirable. Okay, this is like, even if you have or don't, even if you don't have some time also, the production will run. Okay, so the desirable category of inventory is the least important among the three. Unavailability may result in minor stoppages in production. Moreover, the easy replacement of such shortages is possible in short duration of time. Okay, example, the same machinery I'm running, I have my power supply infrastructure, but there is a huge heavy body. Okay, if it is run in the normal floor, what will happen? So the floor get damaged. For that, to avoid that, we'll bring a vibration pad, damping pads. Okay, so we'll run 1 or 2 days. Okay, normally after once reach to the factory or college, the damping pads will keep in below that, so that your floor will not get damaged. But 1 or 2 days we have to manage. So even if you don't have that damping pads also 1 or 2 days, the functionality is not getting stopped. But as soon as you have to replace that. So this is a VD analysis. Basically, it is classified as per the functional importance. Okay, we'll go to just-in-time system. What is the time? 11:16. So up to 12, right?
Yes, sir.
You're feeling bored?
No, sir.
No, you can say no issue. Okay, I will do one thing. I will complete this just in time. This is very important because this is a very similar, very near terms to my ABC. That's why I'm putting this just in time today. So we'll go directly just in time. Just in time. Name itself is saying just I need this material. So okay, I received this material this time, like morning I need 10 o'clock, so morning 8 o'clock I received, so within 2 hours the quality check will happen, get over, so my material is whatever my requirement is getting fulfilled. So what you understanding from here, here you can understand that I am, my requirement is getting fulfilled, and the inventory I'm not keeping inside my factory. Okay, and this kind of advantage you will get in just in time system. Okay, generally we uh, will use this in lean production. Okay, just in time is repetitive production system in which processing and movement of material and goods occur just as they are needed, usually in small batches. Okay, but don't try to use this in big components. That is A category. You have to use this. Maybe you can give for B or C. Okay, C. Okay, I need around 100 bolts today. Okay, it is reaching to my factory today morning. Okay, so even if you don't reach to factory around 2 hours, what will be the consumption? Around maybe 10 bolts. So those 10 bolts I used to have in inventory. It's not mean like I don't keep any inventory, but I'll keep very 10 percentage inventory, but I play with just in time, so that I'll save inventory carrying cost amount. So that is the main intention of this just in time. Okay, so but if you apply this kind of things in a bigger material like bearing, so you will have more problems. It means I don't have any material. I will say that see, this is a huge cost of bearing, around 5 lakhs bearing. Okay, if I keep in inventory for 1 month, it's around or if I bring this 20 days before, what will happen? The 20 days inventory cost will go to the factory. That's why I will bring only today morning. So what will happen? So bearing will reach to the factory. You will face some problem in the quality check. In that case, that again you have to either you have to resend back to the factory, or you have to ask supplier to come to your factory to repair that bearing. How much time it will take? If it is getting resolved within 2 days, fine. The most of the times it will get reject. If it is reject, then actual picture will come in into the factory. Like the lead time of the bearing around 3 months. You have to wait 3 months until that your production will stop. Okay, so that is why most of the times A category material, they won't apply these kind of strategy. If they apply, the company will get going to face big problems. Okay, even that's why most of the times A category material will bring to the factory 20 days or 30 days before. Okay, even though inventory cost is give problems to the company, but these kind of surprises will not come into uh, face any companies. Okay, so just in time is characteristic of lean production system. See, lean production is something like there is any company, there is small team. Okay, so what they will do, they will try to find where they can save some little amount from the inventory, or by doing they will roam in each department. Okay, so they will try to find where I can optimize this process, I can save some money, where I can save some material to bring to avoid inventory carrying cost, or from supply chain. Instead of bringing 50 materials from supplier today, if I bring tomorrow entire lot at a time, so that 1 day transportation will get reduced. So these kind of activities will comes under lean production system. Okay, so just in time operates with very little fat. Okay, it means the fat is a little amount of inventory they will keep, and that little savings they will do for the company. So what is the goal? Just in time goals are eliminate disruptions. Okay, and make system flexible by reducing setup and lead times, eliminate waste, especially excess inventory. Okay, source of waste like overproduction, waiting time, okay, unnecessary transportation, processing waste, inefficient work methods. So as I said, they will go each and every department and they will try to apply this lean manufacturing methods. Okay, in that this is a just in time is a one tool in that lean manufacturing process. And product defects. Okay, what are the 10 elements of just in time? So most of the times this question asks. So workers are cross trained to use general purpose machines. Okay, see, when you try to apply this just in time in factory, so you're bringing some small risk to the company. It means uh, see, there is a bolt here, there is a bolt required. Okay, but the task of bolt without having threading, okay, around 5 rupees. If with the threading, around 10 rupees. So what they will do? So they will try to bring a solid part, and they will try to ask inside that machining people, can you make this threading, because our threading cost around 2 rupees, supplier is costing 5 rupees. So there we can save 3 rupees. So these kind of, if you are thinking, so your inside factory people also properly trained. Okay, that uh, to fulfill that just-in-time method. So that's why workers are cross-trained to use general-purpose machines. General-purpose machines are grouped into cellular layouts to process a family of parts. Okay, and see, as I said, I'm bringing now the bolt. If I'm bringing bolt, nut, some kind of washers, and some other small material, for most of the material they require 2 to 3 machines only. So those 2 to 3 machines, they have to keep one layout. Okay, so in that layout, in that, I request you to all put mute. Okay, so in that process, whatever the operations required, small operations, so related to the machines, they will keep in one place or layout. That's why cellular layout. In that cellular layout, when you uh, want to make some changes, okay, so all machines can available in that same place. Okay, so full production system produce parts and sub-assemblies when needed by the next customer. Okay, the Kanban production control workers are signaled to produce a fixed quantity or their customer by a signal. So this Kanban system is generally very useful in manufacturing sector. Okay, like to avoid shortages. Why generally we avoid shortage? Why shortages will come? Either suddenly they consume the material from the warehouse without giving notice. So what will happen? They won't update in SAP or system. They will take the material from the warehouse. So there you will have face this kind of issues. To avoid that, what they generally do, they have a Kanban cards. Okay, in that cards, what will happen? So the particular machining people department. So I need to do machining of this part. For that, they will come and they will take some machining tool and they will write in that card and they will give to warehouse people. Okay, and they will take that particular tool and they will go back. Okay, and this card system generally will work very efficiently. Even if they've missed also, this card will give alarm to this concerned warehouse in charge. So if that manager will come and ask, okay, why these cards are lying outside? So it means the problem will going to come. So kindly do this needful. Can you make this cards to update in your system, or if that machining tool process over, then can you bring that tool again? Can you keep it in our warehouse so that cards will get count will get reduced? So these kind of methods most of the time companies will in warehouse section they used to use. So this very efficiently working Kanban system. Small lot production required because of restrictions on both space and financial capital. Quick setups. In order to produce in small lots, machines have to be changed over frequently. Uniform production levels. Uniform production levels are made each day. Quality at the source. Workers produce in small lots and inspect their own output. So this generally uh, all these four terms, okay, related to when you apply just in time inside the factory. Okay, it's not like you are going to bring some material saving, not like that. So you are going to make this just in time inside the factory. So example, like uh, you are going to apply just in time for some department like machining or product fabrication section. So there after making this product, immediately there should be a quality source to inspect that material, and you need to have show that I made that just in time for these materials. I succeeded. Okay, that's why the quality assurance person should be there. Okay, and total productive maintenance, an advancement over breakdown or preventive maintenance. Okay, you made just in time, but with that any problem happened, okay, that we should have to predict in very before. So that comes under maintenance. Okay. The supplier network, develop long-term relationship with small number of suppliers who are located near the manufacturing facility and practice just in time themselves. Okay, this is very very important. That's why if you see any companies, see why the Hyderabad like having more suppliers, why we don't have? It's because most of the companies, BHL and ARCA, these kind of big manufacturing companies or private public sector companies, they don't produce everything in house. They I try to go to subcontracting. Okay, this machining I don't have facility. Then what will happen? Somewhere outside supplier, they will try to build uh, small scale companies, small scale industries, micro, okay, micro nano industries. They will form, and they will try to supply the materials whatever this company needed as a just in time policy. So this policy also we have to be trained to them, because see, I need morning 10 washers. Okay, if you don't tell this how this process just in time working inside factory to that supplier, okay, sir, you morning you need, right? I will supply day after tomorrow. No, it will not work like that. In that case, your production will stop. So in that case, what he will do? Okay, this company they need around monthly 1,000 washers or 100 washers. If they want 100, they may ask in 4 weeks, each week 25, 25, 25. So 4 weeks around company will run. So 100 they need average quantity. So I need to have first week around 25, so that if they come immediately I can give. Second week maybe 50. So it means you don't having inventory inside the factory, and also you are educating to your supplier that with schedule wise, okay, you don't keep 100. So average I need first week 25, you keep 50, don't keep 100. If you keep 100, this is the inventory cost for you. So if you try to explain like this to your supplier, he will be more confident, or he will try to keep the capital income to the another product. So he will also get developed by saving your inventory carrying cost. Our company will get developed. So this is a mutual understanding should be there with both the companies. So this what we did in company. In we made so much uh, uh, savings by categorizing C. I mean, once I joined my company, the first task they have given, that is hectic. Like they've given me 25,000 materials numbers, 8 digit number, and eight, and there is a description. Okay, 121008. This is bolt of some 18 dia, something like that. So like that, around 25,000 material list they have given, and this is like one training or test. Can you make ABC analysis and categorize in Excel? Okay, I thought, okay, it's simple work. We studied in college just in time or ABC, okay, something like that. But when you come to reality, you will actually face to categorize that. I took around 2 months time, because I don't know what kind of bolts, so many there, and there are different bearings. Bearings, you can see there is a simple word, but actually, if you go to there and see the physically, there is a 1 lakh bearing is there, around 50 lakh bearing is there, and how I know that without knowing that physically and cost wise, how can I uh, add to A category, B category, C category? So that's why, so this kind of experience you may have, you will face in future. So that's why I'm telling these few basics are very needed in the company. Even if you forget also no issue, just in the company anyway, you have a free time, you just go and ask your manager or just Google it and go to see. I used to keep my books too in my desk. One is material science and this PPC and design of machine elements, and 2 3 books I used to keep because whenever I got doubt, I can't ask because you are already hired. You can't ask them because if you ask, they will get doubts on you whether you passed or something you did. So that's why you just keep some books always. So you try to gain knowledge or recollect from those books and apply those techniques in company. If it's already applied, you will get satisfied. Okay, whatever I studied, I am seeing in the company. If it is not applied, you just try to apply because this reorder point purchasing order method I applied. Okay, so that is the first that for them it is a 25,000 material, right? That is the initial stage of the company that time. So I did for this analysis ABC and I made this C category material immediate purchasing order release. From that annually these many hours I saved. So for that I got appreciation. So like that, whenever you find there is a gap for development by adding your knowledge to that system or process, you can apply. Not only this, uh, when I worked in castings also, I used to study different casting methods. If I use this material, whether I can save. So these kind of things also will be you can done in that. Okay. So I hope I'll stop here. So we have in this one small topic left, that is PQ analysis and one problem. So after that, we'll go to MRP. Okay. Is it okay?
Yes, sir.
So because I'm completely sharing my experience, because anyway you will see these kind of situations there, so you will get familiar by the time. Okay, you have any doubt, you can send a mail to me, so I'll reply that. Thank you. We'll meet tomorrow.
Okay, sir. Thank you, sir.
Thank you, sir.
Bye. Bye.